So we need to find first 4 non-zero terms of the given Taylor series for the given function centered at A, and we also need to write the power series using summation notation. Well, let's review the Taylor series expansion of function f of x centered at x equals a. So f of x equals f of a plus f prime of a times x minus a plus the second order derivative of f of a times x minus a squared over 2 factorial plus the third order derivative of f of a times x minus a cubed over 3 factorial and so on. Well, now let's try to write this Taylor series for our function. So in our case, f of x equals x times ln of x minus x plus 1. And if you look at it, f of a is actually f of 1, and it equals 0 in this case. So let's calculate all the derivatives. So we start by calculating f prime of x. This equals x times 1 over x plus 1 times ln of x minus 1 plus 0. So we can simplify. This equals ln of x and then we calculated at a, so f prime of a, which is f prime of 1, equals ln of 1, and it equals 0. Now let's calculate the second order derivative of f of x. It equals 1 over x, and the second order derivative of f of 1 equals 1. Now we will find the third order derivative of f of x. It equals negative 1 over x squared, and the second order derivative of f of 1 equals negative 1. Finally, the fourth order derivative of f of x equals 2 over x cubed. Then the fourth order derivative of f of 1 equals 2 over 1, so just 2. The fifth order derivative of f of x equals negative 6 over x to the fourth power. Then the fifth order derivative of f of 1 equals negative 6. Well, now let's substitute these values into our general formula of Taylor series. We will get that f of x equals f of 1 plus f prime of 1 times x minus 1 over 1 factorial plus the second order derivative of f of 1 times x minus 1 squared over 2 factorial plus the third order derivative of f of 1 times x minus 1 cubed over 3 factorial plus the fourth order derivative of f of 1 times x minus 1 to the fourth power over 4 factorial and so on. And this equals, so f of 1 is 0, so it's 0, plus f prime of 1 is also 0, so it's 0 times x minus 1 over 1 factorial, plus a second order derivative of f of 1 is 1, so it's 1 times x minus 1 squared over 2 factorial, plus the third order derivative of f of 1 is negative 1, so it's negative 1 times x minus 1 cubed over 3 factorial, plus the fourth order derivative of f of 1 is 2, so it's 2 times x minus 1 to the fourth power over 4 factorial, plus the fifth order derivative of f of 1 is negative 6, so it's negative 6 times x minus 1 to the power of 5 over 5 factorial, and so on. Now let's simplify this a little bit. This equals so here we have 0 plus 0, then we have x minus 1 squared over 2 factorial minus x minus 1 cubed over 3 factorial plus 2 times x minus 1 to the 4th power over 4 factorial minus 6 times x minus 1 to the 5th power over 5 factorial. We can simplify it even more, and we will get that this equals actually we don't need to simplify it more. So we have our first 4 non-zero terms of we have the first 4 non-zero terms of this Taylor series, and now we need to write down our power series with summation form. So f of x equals the sum from n equals 2 to infinity of -1 to the power of n times x minus 1 to the power of n over n times n minus 1.